Alright, we had Carter shoot one of his shots, and we see that his release is a little above his head, so I'm going to put that at approximately 78 inches. The 3-point line to the backboard where the ball hits is approximately 240 inches as well, and since Carter hits the backboard in that video, we put the maximum Y displacement as 126 inches. When we see it here, we see that the ball reaches a maximum a little above the backboard. So if I overlay the two images as such, we see that it reaches that peak at approximately 135 inches away in the X direction and about 13 feet or 156 inches in the Y direction. So we could do a couple things with this. We put it into Desmos, and we see that if we plot the release, highest point, and backboard shots, it does not really look like a quadratic. This may be due to inconsistencies in measurement, or we just got bad data as a whole. Anyway, so to do this, we utilized vertex form, which is applicable to quadratics, and the form is a times x minus h quantity squared plus k. So our vertex, as we saw before, was 135 inches in the x direction and 156 inches up in the y direction. So we did two estimates here, one starting from the release point and one starting from the point where it hits the glass. For the backboard equation, we got negative 0.00272 times x minus times the vertex, and we see that it pretty closely tracks the highest point in backboard as gravity would, and if we overlay it, it's pretty good. But if we look at the release equation, which is negative 0.00428, and then the rest of the vertex form, it tracks it with a little bit more inaccuracy at the backboard end, but is closer than the discrepancy in the previous estimate. So now let's take the first derivative of this release estimate. If we use the chain rule, or if we expand it out and then use the power rules and such, we get f prime of x is equal to negative 0.00856x plus 1.1556. If we set this equal to 0, we could possibly see a point where the derivative is either undefined or equal to 0, which means a maximum or a minimum. So we set it equal to 0, and we got x as 135 inches. Looks good for now. But is this a is this a maximum or a minimum? So we plugged it into the second derivative formula, so we just took it one more time. A quick derivative tells us that f double prime of x is equal to negative 0.00856. And this means it's always concave down, and that is a maximum. So if we look back here, it does look like a maximum because gravity is a negative parabola.